Good morning. Trying things a little differently today than I've done in the past. We're going to be working directly on the screen with the material. You will find the handout that goes with these notes attached to the main lesson for today. Let's go through the notes first. One-step inequalities. When solving an inequality, you use the same, let me fix this, the same steps as solving an equation. The goal is to, of course, isolate the variable using inverse operations and properties of equality. Things we should always keep in mind. Okay, let's look at these four examples. First one, we have a -4 on the right, so I'm going to add 4 to both sides because my goal, as usual, is to isolate the variable. So then I end up with 16 less than or equal to 2x. Divide both sides by 2. And my answer is 8 is less than or equal to x. It's kind of a sloppy x, but it is an x nonetheless. Let's look at the second one. I've got a positive 6 on this side, so I need to subtract 6 from both sides. I'm left with 3x is less than -21. Divide both sides by 3. And I get x is less than -7. Number 3. Now this side I've got x divided by 2 plus 8. So let's move that 8 to the other side. So we begin to isolate the x. So I'm going to subtract 8 from both sides and get x divided by 2 is less than -12. And since x is being divided by 2, the inverse operation is multiplication. So I'm going to multiply both sides by 2. And I end up with x on my left and -24 on the right. I'm going to put a box around this so it's easier to see. Okay? So, example 4. X is greater than 1, x divided by 4 is greater than 1/2. Again, I'm going to multiply both sides by 4, and I get x is greater than 2. Okay? Just a little quick review on one step. So now we're going to talk about negative numbers. Sorry, I didn't mean to scribble. Down at the bottom, we're going to look at this chart to see if we can figure out why this next process is necessary. So let's think about this inequality. 4 is greater than 1. True fact. We all can agree on that. So we're going to look at each of the statements below and replace them with either a greater than, less than, or equal sign. So 4 times 3 is 12. 1 times 3 is 3. So this this is greater than. 4 times 2 is 8. 1 times 2 is 2. So again, greater than. 4 times 1 is 4. 1 times 1 is 1. So 4 is greater than 1. Now 4 times 0 is 0, and 1 times 0 is 0. So that statement is equal. Now let's look at this. 4 times -1 is -4. So let's just write it over here so we can see what we're talking about. And 1 times -1 is -1. Well, we know for a fact that -4 is less than -1. 4 times -2 is -8. And 1 times -2 is -2. -8 is less than -2. And 4 times -3 is -12. 1 times -3 is -3. So we get less than. Now let's look at these questions. What do you notice about what happens in the inequality sign after you get to 0? So if you would just type in your answer there, I'll be able to look at it after you submit. Can you explain that change in your own words? Okay, take a minute to do that. and then I will move on to the next page. Okay, so multiplying or dividing by a negative number. As hopefully you've just discovered, with an inequality, when you multiply or divide by a negative number, you end up flipping, not a very mathematical term, but you're switching the sign from whatever you started with to whatever the new sign is. Okay? So if you're a more visual learner, which some of us are, here's another example. You can see it on a number line. Maybe it'll make more sense. So if A is greater than, here's A, is greater than B, then that means that B is closer to 0. So when we multiply or divide by a negative 1, then A and B both become negative. Negative B is still closer to 0 than negative A, thus negative A is less than negative B. So in summary, you can see that A is greater than B to start with here, and when I multiply both of these numbers by negative 1, then negative A becomes less than negative B. Even though A is a larger number, when it's multiplied by a negative number, it becomes a larger negative number, thus making it less than the original number. Now, even though these numbers aren't to scale, hopefully you can still get the picture and figure out what's going on. Let's look at one more example. Another way you can approach this. Elizabeth is solving the inequality negative 2x plus 5 is greater than 1. She's not really comfortable or unsure about how to treat that negative 2 in the inequality, so she uses the addition property of equality to rewrite her inequality. She decides, I'm going to get rid of that negative number in front of the variable so I don't have to deal with it and get confused. So this is what she does. First, she takes, right, in this step, adds positive 2x to both sides, thereby leaving the 5 here and leaving it as 5 is greater than 2x plus 1. Then she subtracts negative 1 from both sides and is left with 4 is greater than 2x. Again, we're trying to isolate the variables, so she divides both sides by 2 and gets 2 is greater than x, which is the same as x is less than 2. So if you're anything like me, I'm always more comfortable with my variable on the left-hand side than on the right, but I have to make sure that the sign stays in the same direction as it did in this particular problem. So was her answer correct? Yes, it should say Elizabeth, not Rakia. So let's look at these examples. I'm going to do the first two, example 1 and example 2. And then we'll do the other two, and I'll let you do those separately. So example 1, negative 3x is greater than 9. I'm going to divide by negative 3 on both sides. I get x and negative 3, but because I've just divided by a negative number, I know that my sign has got to switch. Well, let's check it. I'm going to check down here. So if I substitute negative 3 as my value for x, hold on, let me fix that. That was kind of sloppy. Okay, so if I substitute negative 3 in place of the x, then I get negative 3 times negative 3 is greater than 9. 9 is greater than 9. I know that is not true because it has to be 10 to be greater than 9. But over on the left, I've said that x is less than negative 3, not that it's equal to negative 3. So be careful when you're doing those checks. The second problem says y divided by negative 4 is less than or equal to 3. So if I multiply both sides by negative 4, then I end up with y on this side, negative 12 on this side, but I've got to switch my sign so that y is now greater than or equal to negative 12. Again, if I do this check down here, I substitute negative 12 in place of the y, and I get 3 is less than or equal to 3. And 3, in fact, is equal to 3. Okay, so in these other 4, I'd like you to go ahead and do the problems. Type in your answer. If you've got a Mac, you can type in that less than or equal to or greater than or equal to by pressing the Option key and then pressing on the greater than or less than symbol to get the equal part. If you have a PC, I'm not quite sure how you do that, so if you just draw a line under it, that will be fine. So that's the lesson for today. There is homework attached to this, which needs to be completed, as well as an exit ticket. I also expect you to do your 15 minutes of IXL before 9 o'clock tonight. If you didn't get it finished on Wednesday and you do 30 minutes of IXL tonight, I will give you full credit for it. Thanks. Have a great day.